Hi, everybody. Welcome to ArcGIS Pro, your spatial data science workstation at the 2021 Developer Summit. We are very excited to talk about all things spatial data science and really kind of give you a whirlwind tour of how Pro can really be a key part of your spatial data science workflows. But before we jump into it, let's introduce ourselves. So I'll start. I'm Lauren Bennett. I lead our spatial analysis and data science software development team. And I'm very excited to be here this morning. Atma?
Hello everyone, I am Atma Mani. I'm a product engineer on the ArcGIS API for Python team. I'm very happy to be in this talk. Alberto?
Hi everyone, I'm Alberto Nieto. I'm a product engineer in the spatial statistics team. I'm also happy to join you here today. Next is Sean.
Hi, I'm Sean Walbridge. I am the lead Python developer on our geoprocessing team and looking forward to this talk.
All right, with that, let's just jump right in. Now, before we get into spatial data science inside of Pro, I just want to get us all on the same page about spatial data science kind of more generally. We really think about it as being all of the pieces of this bigger spatial data science workflow. It's not just the algorithms and the tools, it's also those techniques that allow us to do data engineering, getting our data ready for analysis, to visualize and explore our data. It's that spatial analysis and the machine learning and AI. It's also big data analytics. Of course, a key part of that throughout the process is also modeling and scripting, whether it's creating reproducible work or automating our processes. And then, of course, sharing and collaboration, getting our work out there. And Pro really has key elements of each part of this process really built into it. And Pro is this incredibly powerful workstation that we can use in combination with all the other tools that we're comfortable with and that we're doing great spatial data science in. But it's this really key part of ArcGIS's spatial data science workflow. So we're going to use these different pieces of that workflow to walk through how Pro can really support you in your analysis. So we're going to start with data engineering. Now, data engineering is, I think for most of us, we would probably say it takes up probably the most time in our analysis process. And I know, at least for me, it's probably the least fun. It's not when I'm answering questions and digging in. It's the work I have to do to get ready to get to the fun part, right? So it's figuring out what's missing, what's wrong with my data, how can I add more variables, how can I add context to my data, how can I geo enrich it, maybe it's even as simple as geocoding, transforming that data, all of these different pieces of that puzzle to get my data analysis ready. So Pro is certainly a very important part of that data engineering workflow. I would say that we have been working really hard, and as a little sneak peek of something that's coming towards the summer is a new data engineering experience inside of Pro that's going to allow you to quickly explore the fields in your data, get a sense of their distribution, get a sense of some summary statistics, get a sense of what's missing, and give you quick access to a number of different data engineering tools that we've been working really hard to build in to ArcGIS. That's just a little sneak peek. There's already a ton of stuff built into Pro that's going to allow you to do a lot of rich data engineering, and Alberto is going to show us that.
Hi everyone. In this example, I'd like to share with you how we can go from an empty project like this to a project with a completed data set that can be used for visualization and analysis. And also share with you a few data engineering tips that I found helpful as I try to be productive. So for this example, we're going to focus on unemployment across the United States over the past year. And the first step, usually with data engineering, is to find the data. So a quick web search might land us at the Bureau of Labor Statistics, which has a table that has this data. And from here, a lot of data engineering workflows might proceed to use Python to process this, right? You could import requests to make a connection to the data and then use pandas to create a data frame and so on. But actually today I want to share with you just a few tips that I think are really useful. Tip number one, check if someone has already engineered the data for you. And what I mean by that, we have a connection to the ArcGIS Living Atlas of the world. check there if you already have unemployment as a layer that someone has already curated for you. And in fact, we do. And that can be really useful to gain a lot of time, even as a developer. So we have counties with unemployment already from the Living Atlas. But from here, I do want to take a few additional steps. So tip number 2 rather, is to use Jupyter Notebooks to actually take notes. So for example, you can create markdown cells to go from a quick scribble of what you have in terms of the table. In this case, the table that we downloaded from the Living Atlas has counties as rows and unemployment months as columns. But what I know we need to have for analysis purposes later on is we need a single unemployment field and then a date field with all the months. And then counties can be repeated all the way through the last county. So there's some steps we need to take here, right? And what I like to do is use the notebook to take some notes on what we want to do. After you fill in those steps with Markdown, you could conceive of this being essentially your pseudocode, right? Your plan for doing data engineering. In this case, it's pretty straightforward. We need to transpose the fields to pivot the table. We need to add a date field and retrieve that data information from the headers of the input. And then we can also use some of the new data engineering tools to change the distribution of unemployment to a normal distribution, which can be really helpful later. So tip number 2 is to take some notes in your notebooks. Now for the next part, let's say you actually do start filling in those steps with actual code. In a notebook, it makes sense to actually use it for code. So my third tip is to actually consider geoprocessing tools through the GUI as you prototype a data engineering workflow. So for example, I know that for the first step, I wanted to use transpose fields. Now I could do that through pandas, and certainly we can do that there, but I would have to extract the data out, take a few lines of Python to do that, and then get it back in. So I do recommend that you take a look at the geoprocessing tools. For instance, transpose fields happens to do that operation pretty elegantly and fewer lines of code, as it turns out. Additionally, I want to call your attention to new data engineering tools that we released in ArcGIS Pro 2.7. That includes encode field, reclassify field, standardize field, and transform field. And with transform field, that can be really helpful for a lot of analyses where you may want to turn a skewed distribution into a normal distribution or into some other distribution that may be helpful. So once you've run the geoprocessing tool through the GUI, you can also copy the Python command and add it to your notebook here. So in Pro, it becomes a really powerful way to quickly get the Python signature for a tool that you may not be familiar with. Now, I do have a bonus tip. The bonus tip is that scripting doesn't all have to be in Python or in a scripting language that you may conceive of as a developer. As a developer, you can also use Model Builder. So with Model Builder, what I like to do is create diagrams of the process. So let's say you've already completed your entire workflow to produce your output data. Turn all your steps or select them all and add them to a model to quickly create a diagram that you can include with your notebook. And then when you communicate the steps of your notebook, it becomes really easy to talk with non-developers or with other people that are not familiar with the data. And after going through all that, we're left with a finely curated data set that now we can run through analyses and visualizations. Back to you, Lauren.
Next up, we're going to talk about visualization and exploration. So I think probably most of us, when we immediately think about visualization, we're thinking about visualizing our raw data, making maps, making some charts, getting to know our data better. And that's definitely part of it. And we're going to see some of that right now. But that's not all of it, right? Actually, visualization and exploration play a key role throughout the whole analysis process. We actually use visualization and exploration as key pieces of how we interpret the results of our analysis, how we understand those results. They're also a key part of how we tell the story of our analysis and really
recovered fast, and that's a large portion of this country. And finally, this area in blue is really interesting to evaluate because it's almost like the pandemic didn't really affect unemployment there. And you almost see all of Nebraska falling into that category of cluster. So that's a few examples of visualization to explore and actually start to do some analysis. Back to you, Lauren.
Okay, so up next is certainly my very biased favorite part of this workshop, we're going to talk about spatial analysis. Now, we're talking about spatial analysis, and really that's kind of a bigger bucket because I'm grouping together spatial analysis and machine learning and AI. And the reason I'm doing that is because nobody's problem that they need to solve is that they need machine learning, nor is it that they need a buffer, right? It's always about the question that we're trying to answer, the problem that we're trying to solve, and whether we use maybe a more traditional statistical approach to solve that problem or a more traditional kind of overlay, very bread and butter GIS kind of approach, or a machine learning approach or a deep learning approach. Really, all that matters is the approach we're taking the most appropriate way to solve that problem that we're trying to solve? And so while we do, when we're thinking and kind of talking about what spatial data science is, we do call out machine learning and AI explicitly, just so that you kind of are very aware of how much work we're putting into making sure we expand in these areas. I really just want to kind of reinforce that solving a spatial problem using machine learning and AI is spatial analysis. And really our focus should very much be on the problem that we're trying to solve and making sure we find the best methods, the best algorithms, the best approaches to solve that problem, not kind of starting the other way around. So with that, we're going to start with a really cool example from Atma about doing advanced analysis inside of Pro.
Hello, everyone. I'm going to talk to you about working with multidimensional data in ArcGIS Pro. And for that, I'm going to use the example of monitoring tropospheric nitrogen dioxide. As coronavirus became a pandemic across the world, many countries issued shelter-in-place orders. The impact of this was so dramatic that it was visible from space. Here is an article from LA Times that shows the drop in nitrogen dioxide concentration during March of 2020 compared to the March of the previous year in 2019, not just in the United States. Scientists across the world have analyzed data from so many different cities, and they have noticed such observable drops in tropospheric nitrogen dioxide, and they have published it in various journals. The nitrogen dioxide that we measure is a trace gas, and it is produced by burning of fossil fuels. In urban centers, it is usually exhaust from vehicles that causes this concentration. Satellites like Sentinel-5P from the European Space Agency have sensors like TROPOMI sensor that are capable of monitoring these kind of trace gases. The TROPOMI is an imaging spectrometer or a hyperspectral sensor, and it has sensors in the visible and ultraviolet region that helps us monitor the trace gas concentration. The data from these kind of scientific missions usually come down in a file format called netcdf. It's a very common format for sending scientific data, and in this example, we're going to see how we can work with scientific formats using ArcGIS Pro, Python, and notebooks. The first step in our project is collecting all the necessary data, and for that, I'm using notebooks right within ArcGIS Pro. Pro is a powerful data science workstation. It comes with numerous Python libraries that you can use for geospatial workflows. For the ones that you do not have, you can easily search and install them by going to the Python backstage and clicking on Add Packages, searching and installing it. Like this, I installed netcdf4 and Geopandas packages, and I also installed the Sentinel SAT API for searching and querying Sentinel products. Usually, remote sensing projects like this would mean going to the data provider's website, querying in your search strings and downloading the data separately and bringing that to ArcGIS Pro. But now you can use Python APIs like Sentinel API to authenticate against your credentials. Here I'm specifying an area of interest for New York State, and I'm able to run a query and find out all the scenes that match my search criteria. First, I'm downloading data for April of 2020. I'm specifying a start date, end date, my area of interest, and I'm able to view the results, all the matching scenes, in a data frame. This is a Geopandas data frame, and a recent addition in the Python API is to import a Geopandas geodata frame into a spatially enabled data frame of ArcGIS. The advantage is that I can look at the orbit information on a 3D globe. I can interactively check out what orbits are there, and I can decide the scenes that I want to download. Then I can go ahead and in a simple API call, I can download all my scenes into my workspace. I'm doing the same thing for the previous year, which is 2019. I'm specifying the same area of interest and an appropriate date range, and I'm downloading all the scenes. The data for this comes in the netcdf or .nc file format. The next step is to explore what groups and variables are available within this file set. For that, I'm using the netcdf4 API that I just previously installed, and I'm able to print all the different variables and their metadata information. Once I know what these variables are, I know what kind of data that I need to import into my for downstream analysis. The next step is to create a mosaic data set. Here I'm using ArcPy. I'm creating a mosaic data set into my file database, and I'm calling the add rasters to mosaic data set, specifying all of my 2018, 2019, 2020 data and the different variables that I need to import. Once that's done, I'm going to convert this mosaic data set into a newer file format called cloud raster format, or a CRF. Here is a CRF that I exported from my notebooks. From the multidimensional tab, I can pull down the variable picker and I can see these two variables that I just exported, nitrogen dioxide and the quality assurance value. And I can pull down the time picker and you can see various time periods for 2019 and 2020. The way you can understand this CRF is as a cube, and where each of these layers correspond to a particular variable at a particular timestamp. Now we need to represent this appropriately in Python, and for that we're going to use a class called raster collection. Here is my raster collection. I'm passing the path of my CRF, and I'm able to visualize the raster collection as a data frame here, where each record in the data frame is actually a raster object that correspond to either nitrogen dioxide at a particular time or QA value at a particular time. The advantage here is I can easily filter out my raster collection and slice and dice my data. In this case, I'm first filtering out by year and separating, getting two different raster collections, one for 2019 and 2020. Next, for each of these, I'm filtering it by variable, first by nitrogen dioxide, then by QA value. And as a result, I have 4 different raster collections. I can preview each of these individual rasters in the raster collection at any point in time in the notebook, such as this. Now, the important step next is to filter out all the bad cells. From the data from the Topomi handbook, I know that a QA value of greater than 0.75 is needed, and a positive value in the NO2 variable is needed for downstream analysis. So for that, I'm defining a simple raster algebra function, and I'm able to view the result here. Here, I'm filtering out one raster in my raster collection. The idea is I need to do it for every single raster in my 2019 year set, and do the same thing in 2020 year set. And for that, we're going to use an important concept in computing called map reduce. So in map, I'm defining a function that is going to filter out all the good cells in my input raster and produce an output raster. And I'm going to use a function called map on my 2019 raster collection, pass this function, and behind the scenes, Pro is going to take this function, run it on every individual raster, and it's going to output a raster collection. It is going to be much more performant when Pro does it through MapReduce than me writing a for loop and looping through each of these functions. The output of that is again a raster collection, but each individual raster in this is a corrected raster. The next step is to reduce that. And in my case, I want to compare the average concentration of nitrogen dioxide in 2019 and compare that with 2020 and see if there is a noticeable drop or not. And my reduction call here is the mean function because I need the average. So when I call the mean function on my processed raster collection, I get a single raster which contains the value for the entire 2019 April month. I can apply a raster function, stretch it, and take a look at it here. I do the same exact thing for 2020, and I'm able to produce a reduced raster. So the next step is just to save it to disk and view it on the map viewer. Here I have the 2019 and 2020 reduced rasters in my map viewer. Both these rasters have been classified to the same classification scheme, and they have the same symbology, so we can visually compare them. Notice as I swipe, the top layer is 2019 and the bottom layer is 2020. You can visually just see the reduction in the regions of high nitrogen dioxide concentration. Now, this is a very visual way of doing it. If we want to quantitatively know what's the reduction, then we can just do it. In the notebook, I compute the mean of 2019-2020, and we know that there is an 18.12% drop in nitrogen dioxide concentration. This was a very quick example of showing how to work with multidimensional data in ArcGIS Pro.
Thanks, Atma. Now, before we leave spatial analysis, we just want to take a minute to talk a little bit about this idea that while there are literally thousands of geoprocessing tools and algorithms built into ArcGIS to do some of the most sophisticated spatial analysis out there, we also don't have everything, right? We will never have every single algorithm that exists built into ArcGIS. And you really need a way to be able to reach out to other parts of that big data science ecosystem and grab what you need. And so the ArcGIS Bridge is a really good example of that. And Sean is going to give us a quick demo of that in action. Sean?
Another way we can extend ArcGIS for analysis is by using R. R is a very powerful statistical programming language that has a really amazing breadth of packages for solving statistical and other kinds of analysis problems. Many things that you wouldn't really find anywhere else and that are developed by really leading research experts within those fields. We have a package called ArcGIS Binding, or the ArcGIS Bridge, which gives you access to local and remote data and transform data in and out of the most common types that are used within the R community. There's a few different ways that you can use this. Let me go ahead and show you how now. Okay, so what we have here is a notebook demonstrating the ArcGIS Bridge. And we're just going to do a few basic things to kind of give you a tour of what you can do with this software. So the first thing we're going to do is load some packages, including the leaflet mapping library. and also the ArcGIS binding package, which is the name of this package that we've put together. So once we've done that, we can initialize a connection between Pro or server and this particular package, so we can talk to it. And then we can also do things like adding in ArcPy into this environment. So we can use this reticulate package, and then we have access to ArcPy. So this might be useful if we need to call out to some specific analysis functionality that's already in ArcPy but not directly available inside of R. R has its own data types. The idea of a data frame came originally from R and its predecessor S. So we can take our data and convert it into data frames. So we have some CSV data here. We can make data frames. And then we can do all the normal kinds of things you might be familiar with Pandas, doing things like looking at the data in a tabular form in this notebook environment. We also can convert it into R-specific spatial data frames. So that's what these SF representations are, and we can apply a CRS to it. Do a lot of the same kinds of things you probably are familiar with if you've used like the spatially enabled data frame. R has a really amazing breadth of statistical routines. Here we're just going to use it for something very basic. We can calculate something like the skewness of the distribution of the times where these ships are moored. This is transshipment data coming from a fish watching organization. And we can add columns easily, do all the kinds of standard data manipulations. Of course, there's many thousands of packages in that R ecosystem. You could be doing really interesting in-depth analyses here beyond what I'm just showing you as a very basic form. And then once we have that data, we can write it back out, right? We can take it, we can write it out to a GDB. We can use the rest of Pro and the other software we already know to work with that data that's gone through R, been manipulated in R, and had for part of its life cycle, R native data types. And that is done in a way which is round trip complete. There's no lossiness. It deals with the conversion of if you have spatial references or anything else, it knows how to deal with those, convert them into the native R representations. And then finally, we can kind of tie it together by using that leaflet module. We can take this data that we have, plot it on a web map, embedded in this notebook. We can also then call back to ArcPy to do something like a more sophisticated analyses and generate some clustering output, and just really kind of combine everything to kind of meet our needs, really do something deep in R, but stitch together an analysis story that lets us use all the things that we already have in the Spatial Data Science Workstation and also extend it into this domain where there might be an audience within your organization who's really familiar with R, but maybe less familiar with JS. So you kind of get this nice combination. Thanks.
Thanks, Sean. Okay, so up next, we're just going to talk really briefly about big data analytics. It's a huge area of development for us, a lot of work being done on kind of building out those spatial algorithms and spatial problem solving in a distributed way so that you can use these algorithms on these massive data sets that you've got. And there's a couple of different aspects of this work that I think are worth talking about today. One, in the context of ArcGIS Pro, is something called a big data connection. This is actually a really useful piece of functionality that exists in Pro that allows you to read directly from these collections of data sets in a directory. So it's not uncommon with really large data that instead of storing it in one massive file, we actually store it as a series of files, whether that's a series of shape files in a folder or a series of CSVs in a folder. And so you can point to those directories, treat them as a single file when running through your analysis, but not have to actually change the data itself. So a really powerful bit of functionality that I think maybe is somewhat lesser known, but incredibly valuable for dealing with this kind of large data. It's actually really useful even if your data isn't necessarily big, but just is sitting in these kinds of collections of data sets. So I think it's got really broad applicability. And that brings us into modeling and scripting. There is a lot to say, and what I'm going to do is pass it over to my colleague, Sean Walbridge, and he is going to dig into modeling and scripting and all of the different kind of ways that this part of the spatial data science capability really can be leveraged inside of ArcGIS Pro.
Thanks, Lauren. I'd like to talk to you a little bit about modeling and scripting, which is taking what we provide and combine it into new things through models or even writing actual code to do things in a more in-depth way. Now, most of you here are probably programmers. You're at the Dev Summit after all, but there's a few different aspects to this I think are worth covering. One is just that our commitment to Python and to the data science ecosystem has really grown dramatically. So if you see, looking back at about 10 years ago, that was really when we added Python to what we have available, and we added ArcPy, we added the Python window. That was really about automating the desktop software itself. But as time's gone on, we've added lots more functionality to that, giving you access to just do things in a purely programmatic sense. And with the addition of the Python API and a number of other components, we've really kind of turned the corner from just doing it as a Python developer to this kind of idea that you can do these really interesting data science oriented workflows as well using our product stack. So within that, there's kind of two speeds of technology that are being deployed. There's things that are foundational level technologies. These are things like ArcPy or ArcGIS Pro, the REST API. These are pieces of technology that we build them, we give them to you, and then generally we want to make sure that those are as stable as possible and that there's as few breaking changes as possible, and that you can write code, give it to someone else, and know that it'll be working a long time into the future. Of course, there's certain scenarios where that's not possible, like for example going from ArcMap to Pro with the change from Python 2 to 3, but generally that's the case, that those technologies are stable and require little change. There's also things that are happening in the broader ecosystem that I've labeled here as growth. These are things that are just really fast moving, and there are things that are changing very quickly in the broader Python world, and so we're trying to make sure that we also have something that can adapt to those changes. So these things include the Python API, some of the work that we're doing with R. And yeah, this kind of trajectory you should expect to continue to grow. We're always looking at how we can make what we do better connected both across the different products within ArcGIS and also make the core experience of the data science workstation better. So when we talk about modeling and scripting, you've probably touched at least some part of this in your own work. But you might not be aware of exactly all the different ways you can access modeling and scripting. Many of you have probably used Model Builder. You might have even started with Model Builder. It's a common onboarding work path for folks as they start with Model Builder and then they transition into writing Python code later in their careers. But there's a lot now in the box that lets you do automation. So of course Model Builder is still there. You can create Python and R scripts. You can put those into toolboxes. Those are all really great tools for you. You also, of course, now have notebooks. You have notebooks both in the hosted context, but within Pro, you have them directly embedded. So you can ship and as you've just seen in some of the great demos, you can ship them directly in your project files. You can have them be interacted with and move back and forth. So it's just another way that you should think about, hey, I can embed Python in a way that maybe I wouldn't have. Normally I would have made a script tool and just exposed some parameters. Now I have this really rich way of having someone do code but not have to necessarily get into all the details, but still have some control over exactly what's happening. And then, another piece of this is that we have this foundational distribution, this ArcGIS Python distribution, which is about 150 packages that we ship with Pro and Server and many other environments that are always there for you consistently. So when you're writing your own scripts, usually you can just look in that collection of packages and find something to do the kind of work that you want to do. So you won't necessarily even need to install anything. You won't have to go through IT to get changes on your machine. There's a lot really built into that. And the last thing is Conda. We've done a lot of work on adding this extensibility point of Conda, and that's really allowed us to do a lot to make these consistent environments that can be shipped and deployed into different contexts. And here's just a few examples of some of these things, some of the places that you can interact with Python and do your work, do your scripting work, do your analysis work, and everything else. So yeah, when you build something, it's always worth thinking about, like, what can I do with it? Of course, often we're in the mode of, like, I need this yesterday, and you just have to get something out the door. But when you can, it's good to step back and say, all right, like, how can I take advantage of this work? When we're writing code, one of the big advantages is this kind of multiplier, right? You can do something once and then use it in multiple different places and contexts. So you can, of course, share it to someone else's machine. You can do things like making services out of it, making a web tool. You could have it, hosted in an online environment, so someone can just hit that as an endpoint, as a REST endpoint, or there could be a UI experience built around that in something like, in Web App Builder or some other environment. And you also can, create notebooks. Notebooks can call GP tools. They can call all kinds of things, and you can kind of use them to glue things together. So you could deploy something to a notebook that someone has access to, and then they're able to, interact with that Python code on their iPad or something, which would not be available directly with the desktop stack. So I think, start with what you have. You kind of are often building up, but it's always good to think about, how am I going to help my future self when I'm doing something? How am I setting myself up for success down the road? And how can I make what I'm doing fit better with what my organization's doing? And there's kind of a progression from using simpler tools like Model Builder all the way up to building Python modules and deploying those as Conda packages. And depending on where you're at, you might, find yourself, oh, actually, I can take this next jump and move one step further over in that kind of progression. So a couple other things I wanted to mention in this space is that there's also a deep learning frameworks installer. So this augments that collection of packages that Pro includes with an additional 98 packages. And they're all GPU optimized. So for some of these, you're really going to want to have a decent GPU for doing certain kinds of deep learning models. But they're useful for lots of other applications as well. You can use them directly. There's a number of tools that call them now. You can call the ArcGIS Learn models, or you can just use the frameworks yourself. You could call PyTorch or do something along those lines. This is an optional install that you can get from this GitHub site. The last thing I want to mention is that the Conda piece of this really does help us tie things together. ArcPy is now Conda installable, so you could have someone who has an environment. Maybe you work with someone who's more data science and you're starting out on that side, but you know the analysis space really well. So they could have an environment, and you could just Conda install ArcPy into that, and it will integrate everything together. We've had some good success doing this in environments like Azure in the past, and you can now do it in your own internal use cases. So we also have this broad collection of packages that we publish. So if you are using Conda heavily, you can just reference them from the Esri channel. We have about 150 packages there. Those are builds of things, many open source things that we've built, and also things that teams at Esri have built. Okay, great. Thanks.
Great, thanks, Sean. For this demonstration, I want to give you a behind-the-scenes look at how we at Esri sometimes develop geoprocessing tools. And that has all to do with what Sean just talked about with regards to using what's available to you and going up in complexity. So first, the context here is that we're looking at a data set of major cities and flu mortality rates over the past 50 years. And this is time series data. For each city, we have a value across all the years. And in time series analysis, something that's really important is to consider change points in the time series and the structure of that time series. For instance, we're looking at one particular city, Minneapolis, and the time series for that city has these patterns where a certain value is expected, but then right around this point, there's a significantly different pattern, at least visibly. So those types of change points are things that we're hoping to detect ahead of something like time series forecasting or some other time series analysis. And it's become really useful to prototype in a notebook in ArcGIS Pro. And generally what we like to do is consider those methods that can be appropriate for finding something like a change point. And then once we've confirmed the research on that method, whether that comes from research or a Python package or an R package, etc., then we proceed to think about the geoprocessing parameters and all of the aspects that an eventual GIS analyst may interact with. So as a developer, it can be a really conducive experience to prototype in a notebook and to handle those aspects of the algorithm here and communicate with the rest of the team. So I want to take you through this notebook very briefly because I find it quite interesting. The idea here is that we're testing a few Python packages that do change point detection to compare and collaborate with our team. So generally speaking, we can install those packages within the notebook. I can package up this example and share it with my colleagues later, and they can essentially execute this notebook and see what we're doing. And I also want to point out a Python module called ArcPy widgets. And widgets can be really useful, quick ways to create parameters for your notebooks. In this case, essentially, I'm having a radio button for selecting a layer that's currently in my table of contents. So I want to perform change point detection on one of these layers. I can change my selection and simply select what I want to do here. So same for value. The value is going to be analyzed for the time series, selecting a date field, a location ID field, and finally the feature ID. So let's say that I didn't want to do Minneapolis. Let's say that we wanted to evaluate San Francisco. There's the feature ID, and there's visibly what appears to be a change point there. In this case, it's pretty rough, but it's a prototype. So the idea is not to be perfect, it's just to check. And then I'm going to evaluate different methods for change point detection as a result. So by this particular method that we're researching, for instance, we see a few different regions of that time series that are evaluated as change points. And generally, those methods have themselves have parameters that we have to consider. So this is a really useful environment to take some notes as we're evaluating what happens with different parameters, with different data sets, with different potential use cases. And then once this is all approved and liked by us, by our teams and our colleagues, then we start the process of creating a geoprocessing tool and thinking about all of those nitty-gritty details that eventually land at what you may see in your geoprocessing analysis window. So that's a brief look at scripting and automation, and a behind-the-scenes look at how we build tools.
Okay, well, last but certainly not least is sharing and collaboration. And I just want to mention how important this is in the context of this larger spatial analysis and data science story. We can do great analysis, but if no one is able to use it to make decisions or to drive action, then it's not very useful at all, right? So these tools that allow us to create story maps to tell our stories to the public or to decision makers, the ability to create dashboards that are live with this kind of living, breathing analysis results. These are really key parts of analysis that are easy to forget about, but the best data scientists are also incredibly talented storytellers. And I think it's really important for us to focus not maybe not just as much energy as we did on the analysis, but certainly it deserves a lot of our energy to take that time to find ways to make our analysis approachable, to make it beautiful so that people can use it and feel confident using it, and so that what we've done is really impactful. Now, with that, it's the end of our workshop, and I want to point you to a couple of resources. We've got a Spatial Data Science MOOC, which I highly recommend. It will be offered again towards the fall of this year, so please join us for that if you haven't already. It's really, really fun. We've also got the Learn site. So if you go to learn.arcgis.com, you'll find all sorts of hands-on tutorials. You'll find sample notebooks, a lot of different resources there that you can use to learn more and get your hands dirty. And also I'll do a shout out for the spatial stats resources page, esriurl.com/spatial stats. A lot of our spatial statistics and spatial machine learning approaches are kind of explained in great depth there if you want to get a little bit into the weeds of and the meat of some of these spatial algorithms. And with that, that's it for us. We're going to take some questions. Please do fill out a survey. There should be a link below this screen that you can go to fill out that survey. We absolutely use that to help us figure out what to put on next year, what worked, what didn't work. So we really read all of that feedback and really appreciate it. So thank you so much, and we'll see you in just a minute. Hi, everybody. Thank you so much for joining us this morning, this afternoon, this evening, whatever time of the day it is, wherever you are. We really appreciate it and are really excited to be seeing all of these great questions coming in. I am Lauren, and I will be moderating the question sessions today. We've got some good ones. I'm going to start with two that feel kind of related that I'm going to pass over to Atma. One is about using a notebook to schedule or automate any task, and the other one is about using notebooks to update a hosted feature layer in ArcGIS.com. So Atma, take it away.
Hi, Lauren. These are really great questions. The question about editing a feature layer using a notebook, a significant part of the Python API, the ArcGIS API for Python, can be used to edit feature layers. I posted a couple of workflows into the chat as a reply to that question. And certainly the user can write that into notebooks and save them out. And if the notebooks are executing on ArcGIS Enterprise or on ArcGIS Online, they can be scheduled for run at certain different intervals. The Q1 update for ArcGIS Online that's going to be coming out later in April will have the scheduling functionality. And the previously released version of ArcGIS Enterprise already has scheduling built in. If the user is running these notebooks in ArcGIS Pro, then you could write a Windows task scheduler and schedule your notebooks to run at any frequency you desire. Or if you would like to just run it within the Pro application, you can export them into a Python script, make it into a Python toolbox, and then execute it, schedule it to run within Pro. So there are a few different ways of scheduling the notebooks. Back to you, Laura.
Thank you, Atma. Of course, I did something on my keyboard that completely closed Slido, but I remember that the next question I was going to ask was for Alberto. While I look for that link again, I've got it. And that was about, Alberto, if you would share your notebook and model from your data engineering demo.
Yeah, so we will share the notebook and the ArcGIS Pro project that we use for the demonstrations. There is an Esri Developer Summit GitHub repository. I'll state it out loud and then I'll write the link to it. It's github.com/Esri Dev Summit. That's ESRIDEVSUMMIT, and I'll post the link on the chat. And we'll link to we'll create a new repository for the demonstration materials from this workshop, and we'll post it there.
Awesome. Thank you, Alberto. Okay, we've got a couple questions. Well, we've got a bunch of questions that are really for Sean around Conda and integrating in other packages. I guess I'll start with the question from Vladimir about R. Do I need R installed on the machine, or just everything is integrated into that R ArcGIS Essentials package? And can other R packages be installed via Jupyter too?
Yeah, sure. It's a good question. So with R, unlike with Python, which just directly ship with ArcGIS Pro, many people have R installed, and it's not something that we ship out of the box. So there's a couple different things you can do. One is you can if you go to the options and then geoprocessing section of Pro, it will automatically detect any existing R installations you have, and you can choose one of them to use from Pro, and it will install this ArcGIS binding package that connects ArcGIS to R into that R environment that you choose. So that's one way you can keep using your existing R, use RStudio, the tooling that you have from the R ecosystem, and then be able to call everything from the Esri side, and also make tools that are R-based tools if you do that. The other side of it is you can also use Conda. If you use Conda and you install the R ArcGIS Essentials package, you're basically getting the ability to use some of the things I showed, so like the leaflet notebooks. You're getting a number of dependencies that we found very useful for doing spatial analysis in R. And then you're also getting the Microsoft R Open MRO client. So both work. That's a little older. It's not the most current version of R, but it is possible to use that. And then Jupyter doesn't directly have a hook for installing R packages, but you can you can just use the command line interface to install things, or you can directly embed it in your own R scripts. You can add install packages commands to add in a thing that the user doesn't have currently.
Cool, thank you, Sean. Well, there's two similar questions. Well, they're the same question, both upvoted quite a few times, so I'll ask that to you too, which is about licensing requirements for working with ArcPy being Conda installable.
Sure. Yeah. So that's a good question. It's not a separate product offering today. So you can install it anywhere, but in order for it to actually execute, it will look for some other licensed product on the machine that does have ArcPy already available to it. So typically that would be like in Pro, but it could also be Server. There's a few other products that contain ArcPy. So it doesn't, it's not a separate licensed product that you can use through that mechanism today. Where it's really useful is like if you had someone like a data scientist or someone you work with who had an environment already, you can just add this one package to it, and now it's able to do everything that ArcPy has. It'll have the Python API, everything else added to that existing environment.
Awesome. Thank you. Okay, next we've got, there's a question about ArcGIS Pro working as a SOLAP, and our kind of take on that as we were discussing it behind the scenes when this question came up is that there's quite a bit of multidimensional functionality built into ArcGIS Pro. It's actually been kind of a huge area of focus for quite a few teams over the last couple of years. So between the wealth of multidimensional raster and imagery analysis that has been built into Pro and across ArcGIS, and the space-time cube capabilities and the space-time pattern mining toolbox for doing pattern analysis and forecasting, as well as using the SEDF to interact with your multidimensional data. There's quite a bit of capabilities that are kind of embedded into Pro, not specifically in a kind of SOLAP approach, but they're really much more kind of embedded into just a bunch of different aspects of ArcGIS Pro and really across ArcGIS. So I would say if multidimensional analysis and data manipulation is what you're after, there's quite a bit you can do right inside of Pro. I don't know if anyone else wants to add anything there. Okay, I covered it. Okay, we also have a question about Geopandas. Geopandas was mentioned earlier. If so, what's the best method for installation into the Pro version of Python?
Yeah, so you should be able to just install it. So if you create a custom Python environment, you should be able to just install Geopandas from the backstage or from the command line. If you're having any problems with that, let us know. There are occasionally conflicts that happen just at the dependency level with the rest of Pro. But if you try it even in the next day and want to come by the Ask Our Experts area for Python, we can help you figure that out and see what's going on there. And there is, I just would also mention that the newest release of the Python API does have some direct compatibility with Geopandas built into it.
There's another one about, is there a way to implement a data disclaimer on maps and layouts in Pro? Now, I will fully admit that this is not my area of expertise, but there is something called a map note in ArcGIS Pro, and we've linked to the doc about that in the reply to this question. That may get you to what you want to do with a data disclaimer. It's quite similar to what you can do in web maps, also with a concept called map notes. But if that doesn't answer that question, that would be another one again to check out the Ask an Expert at the ArcGIS Pro area. They'll definitely be able to give you a lot more details about that. Okay, we have another one for Sean about how do we recommend sharing third-party packages with the user base in a large organization?
Yeah, so there's a few different ways of doing this. One thing you can look at is we use Anaconda. Anaconda is a company that really specializes in this, and they have a lot of infrastructure that you could add to an organization if you really are heavily trying to do a lot with Python. I think it's really worth looking at their offerings. And then, our software can plug into that. I think if you just need to do something lightweight, then you can like make packages. Making packages is a really good first step, because that means you can add dependencies to them and you can collect those together and ship them to people. So you could use Conda for that. You could be using other tools like pip to do that as well. But yeah, I mean, if you have really specific questions about your organization, again, that might be a good one to talk to us in the Ask Our Experts session.
We got a follow-up question to the ArcPy licensing about, so ArcPy couldn't be used on a standalone machine, even if I have a licensing server on my network.
It still needs, so when people say ArcPy, they think of a Python interface, but ArcPy in essence is like, it's this tip of a, it's part of a bigger system. So basically it's able to access all the internals that ArcGIS Pro or the GIS software has, and all that code's written in C or in C++ and other languages. So basically it needs to have that whole thing around in order to execute. And it's not, even though it's a Python package, it doesn't exist outside of the rest of that system being available. The notebook, the hosted notebooks product is another thing that has ArcPy, and it does include all of those pieces in order to drive that ArcPy package.
Awesome. Yeah, I have another one. We got another one here about the MOOC, asking if it was going to be, essentially if it was going to be the same as last year. And I'm using this as a chance to plug the MOOC. So I'm guessing that that person did participate in the MOOC last year and was hoping that we'd have a new one. We don't. It's the same one as last year, but if you haven't checked it out yet, I definitely recommend it. We use a very similar kind of structure in that MOOC, where we walk through these different aspects of spatial analysis and data science across ArcGIS and get a lot deeper into a lot of concepts. And you get to get your hands dirty and actually kind of dig in and use the stuff. And what's really fun about doing it in a MOOC is that you're part of this community. Thousands of people are doing it at the same time. There's a really active network where people are asking questions and helping each other, and we're involved in answering questions and helping you. So if you haven't checked that out, I definitely highly recommend it. I think it's being offered again later this year. We did get one which Alberto is going to answer about, where did it go? Oh, is it possible to launch a notebook script when detecting some events like a change in a geodatabase or something like that?
Yeah, so my take, and that's just one perspective, is that the notebook is, the way I see it is, it's a place where you can write Python code, and it's really useful for prototyping workflows where you may not know what the final full scripted sequence is. And my sense is that you would best use it to do that, right? To develop a workflow that you're not sure of. If you do need this fully automated sequence that checks on a routine basis the status of a file geodatabase or some enterprise geodatabases, you may be better served by having a standalone script that runs continuously as a scheduled task or a daemon or something like that, or some database level scripting that checks for those changes. I think there's other tools that are better served for that. That being said, I'm sure you can still rig a notebook to do that for you. With enough persistence and time, you can probably make that work. I just wouldn't see it as the best utility of a notebook. That's just my take on that.
There's another one that I just passed over. That I can take on in the big data connection slide. We mentioned collections of data set. What is collections referring to in this case? So one of the things that we introduced, I believe, last release, so in it was either 2.6 or 2.7, we introduced a concept called a big data connection. And what you can do with a big data connection is you can connect to, for instance, a folder full of shapefiles or hundreds of CSVs. And what you can essentially do is treat those as a single data set. So when you set up this big data connection, it sets up this, it will try to recognize the schema. You can inform it of the schema. It will match across those CSVs, and it will allow you to use that folder full of CSVs as a single data set when you're running it against geoprocessing tools, which is pretty powerful. And a lot of data, I know that we're all dealing with a lot of data that comes that way, whether it's, you know, state by state or day by day, or because it's just massive data. And so a CSV fills up and then a new one starts and you're just kind of accumulating these CSVs. So that big data connection is really useful, not just for big data, but certainly for that purpose, because that's why a lot of data is coming that way these days, is because you max out how big a shapefile or a CSV can be. And so you start a new one. Sorry, there's one about, is it possible to use the GPU for TensorFlow execution inside of ArcGIS Pro? Sean, you had mentioned taking this one.
Yeah, so it's possible. It's if you install the deep learning frameworks or the deep learning essentials package, you'll get that, the GPU optimized version of TensorFlow. There's only a few GP tools that will directly talk to TensorFlow. Most of them use ArcGIS Learn, part of the Python API, which is mostly backed by PyTorch, but you can use it in your own code and you can do analysis and it will be GPU optimized in that case.
We got, we're at time. So we will, I think all of us at one point or another over the next 3 days are going to be at Ask an Expert, and we are there as a resource. We're always here as a resource for you. So thank you so much for joining us today. We really appreciate it. And we hope you have an amazing conference.